Hello everyone, welcome back to our channel. So this is the second part of our engineering curve series, and in this video we are going to discuss about the involute curve. So in the first part we have discussed about the cycloid curve, techniques to draw the cycloid curves, and how you can achieve 6 marks in the final exam. So question will be asked either on the cycloid curve or on the involute curve in the final exam. So knowing both the techniques are very important. So I request you to watch this video till the end, and they will not mention whether you have to draw the cycloid curve or the involute curve. So that how we can identify which curve is to draw, that we'll discuss in this video. So don't skip this video, watch till the end, and only 14 days are left for the final exam. So I request you to concentrate on your studies, don't waste your time, and concentrate on the important topics and prepare them well so that you can easily face the final exam. So we'll start with the question. So draw a hexagonal a, B, C, D, F of 25 mm side. So 25 mm hexagon we have to draw with two of its sides A, B and D being vertical. So they have specifically mentioned that two sides are vertical. So A, B and second side is D, E. So these two sides are vertical. So remaining points are C and F. So your hexagon will look like this in the position. So orientation of the hexagon they have clearly mentioned. If they are not mentioned it, you can draw any type of hexagon. One end of an inelastic string. So when they talk about the inelastic string, they clearly point towards the involute curve. So it is not related to the cycloid. It is only related to the involute curve when they discuss about the string at the corner C of the hexagon. So on C it is attached and wound around the perimeter completely by holding the free end of the string such that the string is always tightly stretched. Remember, these words are only related to the involute. So by reading this question you will come to know that this is the involute curve. Trace the path of the free end and name the curve. So name the curve is already we have discovered that it is a involute curve. Now we will discuss step by step method to draw the involute curve. So focus properly. So first start by drawing the hexagon. The side of this hexagon is 25 mm. I hope all of you know how to draw the hexagon. If you have any difficulty, you can mention in the comment box. We'll make a separate video on the hexagon. So first mention 25 mm side of the hexagon and draw the hexagon in the proper sequence. Two sides should be vertical. Then give the naming. Start with this point. This is point A. Next point is B. Next point is C. Then D, E, and final point is F. So mention all the points of the hexagon. Then we'll find out the perimeter of the hexagon. The formula for the perimeter is very simple. Number of sides into one of the length of one of the side. So 6 into 25. So the perimeter of the hexagon is equal to 150 mm. The corner at which the string is attached, from that corner we have to draw this line of 150 mm length. So from this point C, draw a line of 150 mm length, mention the length and divide this line into equal parts equal to number of sides of the polygon. Here the sides are 6, so divide this line into 6 part. 150 divided by 6, it is 25 mm. So draw it. Use the scale to mark the points on this line. If you don't know, or sometimes if you are difficulty in dividing the line, you can use the method mentioned in the first video. That for that you have to watch the video number 1. This is the simplest method to divide any line of any length. Then name the point P1 dash, P2 dash, P3 dash, P4 dash, P5 dash, and at the end point P. So this is a very simple process. First draw the hexagon, mention the proper dimensions, then draw a line from the point at which the string is attached equal to the perimeter of the hexagon or polygon. So this is the length of the hexagon mentioned over here. Then extend the line CD in this way. Extend this line CD upward. Extend the line D in the upward direction. Extend the line EF, then extend the line AF in this direction. Extend the line AB downward. Okay, this is the second step, right? Extend all the lines on their respective directions. After that, we should take a compass. So take the metal end of the compass on point C and then measure a distance from point C to point P. Use the compass and keep the metal end at point C and keep the pencil end at the point P and measure this length. And then keeping C as a center, draw one arc in the upward direction, just like this slowly up to the next line. So we get this point of intersection. So this point is called as point P1. So this is the first part of the involute. If your compass is unable to take this dimension, what you can do, you can use the scale 1:2 and as per that you can manage. That is also right, but you have to mention the scale. If you're able to draw this curve, it is very simple for you. You don't need to use any other scale. Then we'll go to the point P1 dash. Now keeping P1 dash as a center, we'll mark a distance from P1 dash to point P in the compass and we'll shift to the point D. Now keeping point D as a center, we'll draw the next curve. The radius here is P1 dash to P. So mark the next curve up to the next line. Now this is the point of intersection. This is called as a point P2. Now shift to the next point P2 dash, P2 dash to P. Take this distance in the compass. Now keep the center as point E and mark the next curve up to the next line. Here we get point of intersection. This point of intersection is called as point P3. Now we'll go to the P3 dash point. So from P3 dash we'll measure a distance up to P in the compass. Now keep the metal end of the compass at point F and then draw the next part of the curve. So this point of intersection is called as a point P4. Okay, it is should be point P4. Then next move to the point P4 dash. So from P4 dash measure a distance up to P in the compass. Now move to the center A. So from A with this radius draw the next part of the curve up to the next line, that is line AB. So this is a point of intersection. This is known as point P5. At the end, move to the point P5 dash and measure a distance P5 dash to P. Now keeping this distance in the compass, keep B as a center and draw the remaining part of the curve with that radius. So it will complete your curve in this way. You can use the French curve to make it smooth. When you draw it with the help of proper measurement and drawing instrument, you will get a perfect curve with this method. So this method is very simple. If such type of question is asked in the exam, you should feel yourself lucky because you will definitely get 6 marks easily for this curve. Now mention the name of the curve. It is a involute curve. So you will get the full marks in the final exam. First thing, draw the hexagon with the given position. Then find the perimeter of the polygon. For the polygon, the formula is very simple. Number of sides into length of the side. Then draw the line passing through the string attached point. Then the length of this line is equal to perimeter of the polygon. Now divide this length into equal number of parts equal to the sides of the polygon. Then from each point measure the radius and go on shifting the centers and draw the complete the polygon. If you still have any doubt, you can rewatch this video because this cover is most easy in this syllabus. So if you still have any doubt, you can write in the comment box. If you like this video, please share this video with your friends. All the best for your studies. Thank you very much for watching this video.